Hello and welcome to Algebra 1 and 2, Factor any trinomial in 60 seconds. In this video, we're going to factor trinomials, and we're also going to get into four-term polynomials, but we're going to complete X factor puzzles, factor trinomials when A is 1 or greater than 1, and then we're also going to factor some four-term expressions by grouping, and we're going to apply the difference of squares and perfect squares patterns. Here are some of the standards that we're going to cover in this video. These are from the Florida's Best Standards for Mathematics. So let's go ahead and get started. We're going to use the same steps when we are factoring trinomials, whether the A is equal to 1 or A is greater than 1. And then you're also going to see how these steps also work with difference of squares and perfect squares patterns. And then we're going to tweak them a little bit for some more complicated polynomials. So let's go ahead and get started. So step number 1 is put it in order. So make sure that it's in standard form. Whenever you take your EOC, they may mix up the terms. So just make sure that they're in order first. That way you can correctly identify A, B, and C later. Then we're going to look for a GCF. If you haven't already, you might want to check out my video on dividing with variables and GCF factoring, where this goes a little bit more into detail. So for this one, we have a 1 in the front, and you can put that there if that helps remind you. And if we have a 1 in the front, there is no GCF or number that goes into all three. Then you want to look for a letter that goes into all three, and there is none. So now from here, step 2 is done, and we're going to identify A, B, and C. So when we look at quadratics in standard form, A is always going to go with whatever's being squared, and so for this one it's going to be 1. B is always going to go with your X or your variable that is by itself. In this case, it's going to be negative 17, and then C is going to be our constant 42. And you'll see how we tweak these later for more complicated problems. All right, and then from here, we can now do our X factor, which I covered in another video on completing X factor puzzles, so you may want to check out that video as well. So A times C goes in the top, so this is going to be 42, and then B is always going to go in the bottom. And then we're going to start listing out our factors of 42. So I have 1 and 42, 2 and 24, and then 3 and 14. And I know 3 and 14 can give me a 17. And for it to be a negative 17, it needs to be a negative 3 minus 14. And then we always want to check back with the top. Negative 3 times negative 14 gives me positive 42. So this one is looking good. If my X factor didn't work out, I would just stop the process where I'm at, look to see if there was a GCF at the very beginning, and then there would be no steps after that. We would stop here. But this one did work out. So now we're going to use this pattern that we have over here. We didn't have a GCF for this one, and so now we're going to go ahead and just start writing it in factored form. So we have A, which is 1, and then our variable X. Then we're going to put minus 3, and then we're going to have A, which is 1, X, and then minus 14. So you're putting your first number in here, your second number goes here, and now we're just going to check really quick to see if there's a GCF inside of those parentheses. So is there a number that goes into 1 and 3? No. 1 and 14? No. And so this one is done. And then if you need to go back and check it just to check your work, you would go through and do FOIL or your box method, and then go through with distributing and seeing if you get your original equation, which we do. So now let's try another one where A isn't 1. And so we're still going to make sure that it's in standard form. This one already is. and then we're going to look for a GCF. So is there a number that goes into 5, 34, and 24? If you're not sure, write your factors of your smallest number and then start with the largest one and see if it goes into both of the other numbers. And 5 doesn't. And so we would just keep going from there. So if you're not sure, check it. All right. And then is there a letter that shows up in all three? Answer is no. So now we get to do A, B, and C. And that's going to be my coefficients, 5 and positive 34. Make sure that you're including those signs in there. And then C is going to be 24. If you were to have a negative out in front, just keep in mind that you would need to get rid of that negative first by factoring out that -1 as a GCF. So just keep that in mind. If your leading coefficient is negative, then your GCF is negative, and you would need to get rid of that negative first before proceeding. All right, and so now from here, I have 5 times 24, so I'm going to go ahead and put that in my calculator. 5 times 24 gives me 120. And then B for bottom means 34 is going to go at the bottom. And now I'm going to start listing out my factors of 120. So I know there's a lot of factors in 120, so I'm going to start far apart. And I've got 2 times 60. That can either give me a 62 or a 58, and so I'm not even close yet. And so 3 and 20. And then 4 and 30. And 4 and 30 can give me a 34, 4 and 30. And positive 4 times positive 30 gives me 120. 4 plus 30 gives me 34. Now I can go ahead and start writing. So for this one, I didn't have that initial GCF. And then I have A, which is 5, X, and then plus 4. And then I'm going to do the same thing for this one, 5x, and then plus 30. And then don't forget we're looking for a GCF inside those individual parentheses. So there's no number that goes into 5 and 4, so that one is just going to stay the same. But when it comes to 5 and 30, I know that 5 can go into each of these. 5x divided by 5, 5 divided by 5 is 1. And I keep the x. Positive 30 divided by 5 is 6. And then that is it. And so this would be my answer. And then of course I can go back and check it. Just doing a quick check here, 5x and x would give me that 5x squared. And then I know that 4 and that 6 are going to give me 24. So I'm looking good for this one. I don't need to do a full check on it. All right, we've got 4x squared minus 13x plus 10. Is there a number that goes into each one? No. Is there a letter that goes into each one? No. And so from here, I'm going to identify A, B, and C. A is 4, B is negative 13, and C is 10. A times C is 40. And then B is going to go into the bottom. I'm going to go ahead and start writing my factors of 40, 2 and 20. 3 doesn't go into 40, but 4 does. And I know 5 and 8 can give me a 13. So 5 and 8. And then to get a negative 13, negative 5 minus 8 gives me negative 13. Check the top. Negative 5 times negative 8 gives me a positive 40, so that's looking good. Then I'm just going to take my GCF. I didn't have one. Then I've got 4, which is A, x minus 5, and then 4x minus 8. I'm going to check for a GCF. There's no GCF in this first one. But I know I can divide this second one, both of these by 4, and I get x minus 2. and then this would be my answer. Alrighty, let's try this one. We have 2a squared minus 6a plus 4. It's already in standard form. Then I'm going to check, is there a number that goes into all three? And that is a yes. 2 is the largest number that can go into all three. Is there a letter that goes into all three? No. Then you're going to factor out your GCF. So the 2, your GCF comes out to the front. 2 divided by 2 is 1. Then we have that a squared still. Then we've got negative 6 divided by 2. We're going to keep that a on there. And then positive 4 divided by 2 is positive 2. And then that's why you may want to go back and check that GCF factoring video. Now from here, I have 1 on the inside of here, negative 3, and 2. And then this one is really quick. So 1 times 2 is 2. Then we've got negative 3. I know 1 and 2 can give me a 3, negative 1, and negative 2. So now when I go to write out in factored form, I'm going to put my GCF first, then I'm going to put 1 for a, and then we've got a here instead of x, so just kind of keep that in mind. Then we've got minus 1, and then a minus 2. And then of course there's no GCFs on the inside of those parentheses, so this is my answer. Alright, so now let's try another one. So this one appears a little bit more tricky, right? Because we don't have that x squared at the front. But we're still going to make sure that it's in standard form, 4, 3, 2. So we're looking good there. Is there a number that goes into all three? No. And then is there a letter that goes into all three? I see x being a variable that goes into all three. I'm going to choose the exponent that is the smallest that I can see, and that's going to be part of my GCF. And so x squared is going to go out to the front, and then I'm going to divide. When you divide with exponents, you're going to subtract. 4 minus 2 gives me 2. Then we've got negative 5 divided by 1. 3 minus 2 gives me 1. And then positive 6 divided by 1 is positive 6. And then 2 minus 2 is 0. And so x is no longer seen in that one. And then we've got a, b, and c. And we've got 1, negative 5, and 6. Remember in this part, when you factor out your GCF, your a, b, and c is coming from inside that inside those parentheses. And then from here we have a times c, which is 6. Negative 5 goes in the bottom. And then when we think about 6, we've got 1 and 6 could give me a 5, right? But if I put a 1 and a 6 here, and I put 1 minus 6, it would give me negative 5. But when I go back and multiply 1 times negative 6, it doesn't give me a positive 6. And so those two factors don't work. But if we're thinking about the factors of 6, we also have 2 and 3. So 2 and 3 can also give me a 5. And then to get negative 5, it would be negative 2 and negative 3. Negative 2 times negative 3 gives me positive 6. So just kind of be careful with some of these numbers where you might have some different possibilities. Make sure you're going back and checking. Now from here, we have x squared. We write out our GCF first. Then we have ax, which is just 1x. Then our minus 2. And then x minus 3. There's no GCF for 1 and 2 or 1 and 3. And so this would be our answer for this one. Trinomials like this can look a little scary just because we have a bigger number here on the end. We have some higher exponents, but we're just going to follow the same steps that we've been doing. So it's already in standard form. And now, is there a number that goes into all three? 5 is my smallest number, and I know 5 goes into all of these. And then I also have a letter or a variable that shows up in all of my terms. 2 is my smallest exponent. And now I'm going to write this out to the side. 5 divided by 5 is 1, and then 4 minus 2 gives me 2. Negative 10 divided by 5 is negative 2. 3 minus 2 is 1. And then negative 40 divided by 5, I'm just going to use my calculator. Clear it out. I put 240, then I make it negative, divided by 5 equals negative 48. And then these x's are going to cancel. 2 minus 2 is 0, and so we don't see it anymore. And now from here, I've got A, B, and C. 1, negative 2, and negative 48. I'm going to come over here. 1 times negative 48 is negative 48. And then we've got negative 2 in the bottom. And then I just start listing out my factors. So it started off by looking scary, and a lot of people on their EOCs or on their finals exams or on a test would see something like this and they get automatically intimidated, and sometimes they just skip the problem altogether. But this one actually isn't that bad. And then we've got 2 and 24. We've got 3 and 16. These are going to be numbers that are super close together, right? So we've got 4 and 12. 5 doesn't go into 48, but 6 does. 6 times 8 gives me 48, and that can give me a 2. So I have 6 and 48. Oops, sorry. 8. And then 6 minus 8 gives me that negative 2. And so a lot more manageable than we thought. Here we're going to do AX, and A, remember, is 1, and so we've got X plus 6, and then X minus 8. And then if you wanted to kind of just check this, you could think of it this way. We've got x times x, right, which is x squared. And then if we multiply it by this front number, we're going to get 5x to the 4th, which is what we started with in the front. If you multiply the 6 and the negative 8, you get negative 48 times that front GCF again, and we get that negative 240x squared. So there's a quick way of just kind of checking it without doing everything. And this would be our answer. Now looking at this one, we're going to do the exact same thing. And so we're going to look for a number that goes in all three. If you're not sure, start writing out your factors of 16. So we've got 1 and 16, 2 and 8, and then we have 4 times 4, right? First, check to see if 16 goes into 40 and 25, and it doesn't. Then you can check 8. 8 goes into 40, but 8 doesn't go into 25. And so that's one way of how you can kind of check for a GCF using your factors if you're not sure about what you're doing. This particular problem doesn't have a GCF. So now we have A, B, and C. A is 16, B is negative 40, and then C is 25. And so now I'm just going to pull up my calculator, and we have 16 times 25, and that gives me 400. And then in the bottom we have negative 40. So with this problem, we are going to approach it the same way. Don't get hung up on the fact that we have some larger numbers here. 400 is going to have a lot of factors, so I'm going to split these apart pretty far. We've got 2 and 200, and then you can try 3. So if you're not sure, 400 divided by 3, it gives us a decimal, so we know that doesn't work. And then of course we have 4 times 100, so we're getting closer and closer to 40. And then we've got 5 times 80. And then if 2 and 3 don't go into 400, then 6 can't go into 400. And then 7, and you can just keep trying these if you're not sure. If you're not sure, type them in, okay? And then we've got 400 divided by 8, that gives us 50. So we're getting even closer to 40. And then from here, we know 9 can't go in. If 3 doesn't go in, then 9 doesn't go in. And then we've got 10, right? 400 divided by 10. So if you're not sure about these divisibility rules, use your calculator. Lean on your calculator. I can't stress this enough. And then we can get a 30 and a 50 out of 10 and 40. And it seems like we're never going to reach 40, right? And so we can try out 11. That doesn't work. We can try out 12. That doesn't work. 13. That doesn't work. 14. That doesn't work. 15. And you just keep trying until you get there, or you can finally figure out that it doesn't work. And so now we've got 16 and 25, which is what we first started with, right? Okay, that can't quite give me 40 yet. And 18 doesn't work. 19 doesn't work. But 20 does, and it gives me 20. And so now we've reached doing all of the factors, right? And so this is one of those problems where a lot of people would give up, but it still works out. If you reached the middle and there weren't factors, you would just say that it's prime, it's not factorable. You would see if you could pull out a GCF and stop at step 2. But from here, we know that this is 20 and 20. And then to get negative 40, it's going to be negative 20 and negative 20. So now we're going to go ahead and write it out in factored form. We didn't have a GCF, so 16b minus 20, and then 16b minus 20. I know that 4 goes into both of these. And I get 4b minus 5. And because it's just 2 sets of the same thing, we could write this as 4b minus 5 squared. Now, something about this one is if you had known about your special products, you would have noticed that we have a perfect square here, a perfect square here. So our perfect square of 16, if we took the square root, we would have 4. And then if we took the square root of 25, we get 5. And so then when we look at this middle part here, we have 2 times 4 times 5. And so this is one of our special products, but we now have a way that if we didn't recognize the pattern or recognize that that it was a perfect squares pattern, we could still use the method that we just learned and we still get there. Did it take us a little while? Yeah, because we had some bigger numbers, but we were able to do the exact same thing with the perfect squares pattern and we still were able to factor using this method. So it actually works out for this one. All right, let's try it with a binomial. And so with this one, we're going to do the exact same thing. We're going to look for that GCF, and I don't see one. There's no number that can go into 16 and 9. So now I'm going to identify A, B, and C. For A, I have 16, but remember, B goes with this variable when it's by itself, right? And we don't have one. And so this would be a 0. And then C is going to be -9. In our calculator, we can go ahead and do that. So 16 times 9, make that negative, equals, and we get -144. And if you watched my video on completing X factor puzzles, you would know that this is going to be a perfect square, or it needs to be a negative perfect square. And so this is going to be 12 times 12 gives me 144. 12 minus 12 gives me 0. And so from here, I can do the exact same thing that I've been doing. This one is going to be the same thing, except it's going to be minus. And then we've got 4 going into both of these. And we get 4q plus 3, and then 4q minus 3. And if you had noticed with this particular binomial, that this is the difference of squares pattern, but we were able to use the same method that we've been using. Now, that's not saying that you don't need to know your perfect squares and your difference of squares patterns, because on an EOC or on a final exam, you could get asked questions about those patterns, and it does cut down on time. But if you at least know your basics for factoring and you learn this method, you can get around it for most of it. And so use this. We still get the same thing. Notice that this is a difference of squares pattern. The square root of 16 is 4. And then the square root of 9 is 3. And so this is 4q squared, right, minus 3 squared. And that's how we get 4q. And then for that difference of squares pattern, you have a plus and a minus. That way you can get rid of what's in the middle. So this one is very similar. Okay, we don't have a GCF for this one. Let's go ahead and label out A, B, and C. We get 1, 0, and -121. -121 goes on top, 0 on the bottom. I know this is going to be a perfect square, and so 11 minus 11 gives me 0, and when I multiply that, it gives me -121. So now I have W plus 11, and then W minus 11, and that is our perfect squares pattern working yet again using this method. So with this method, we would have to tweak it a little bit for something that looks like this. So for this one, we can still recognize this as our difference of squares pattern. So when we think about k to the 4th power, that is the same as k squared squared. And then we have minus, and then we kind of recognize this perfect square of 36, being 6 squared. And so we know that this is going to work with our perfect squares pattern. We're still going to use the method that we've been using, and we're just going to tweak it a little bit to work with that k to the 4th power. So for this one, we have A, B, and C. We get 1, 0, and negative 36. And we know that this is going to be 6 minus 6. But when we go to write this out, because we have this k to the 4th, we're going to think, hey, we need this to be k squared instead of just k plus 6, and then k squared minus 6. And when I go back and think about how I'm writing this, this needs to be what I had in the front. And so this is how we just kind of tweak it with this type of problem. But since we know the basis and the foundations of factoring and what it needs to look like when I go back and write it in factored form and check it, it makes doing problems like this a lot easier. But you still want to learn your special products patterns. So now let's try a small tweak for 2 variable trinomials. So still getting a little scary. They're getting more and more complex. So the first thing we want to do is look for that GCF. I have 3, 21, and 30. I know that 3 can go into all of these. And then I see x's in 2 of them and then y's in 2 of them, but they can't go into my GCF because they're not in all 3. So I'm going to go ahead and take that 3 out of there. 3 divided by 3 is 1, and if you need to put your 1 there just to help you remind yourself of what a, b, and c is, then do that. Then we've got x squared plus 7xy plus 10y squared. And then we're going to do our a, b, and c just like we've been doing. And our a is going to be 1, b is going to be 7, and then c is going to be 10. 10 goes on the top, 7 on the bottom. This one's pretty straightforward and easy. It's going to be 2 and 5. And then from here, when we go to write it out in factored form, you're still going to put that GCF in the front. And then our first variable, so when we think about this, we have our first variable here, right? And so we need the x to be in the front, but then we also have a y on the back end. And so instead of just putting plus 2, we're going to include that y on there and then close it up. So then we've got x plus 5, and then we're going to add that y on there and close it up. And then when we think about what this looks like and we're doing our checking, we have that x squared, right, times that 3 in the front, and that gave us what was in the front here. Then on the back end, we've got 2 times 5, which is 10, and then y squared. 10 times 10y squared times that 3 in the front gives us what's in the back here. And so that's a quick way to kind of check it. But now that we know how to do factoring and we know those foundations, it makes problems like these a lot easier to do a small tweak to kind of fix them up. All right, let's try another one of those. And so we're not going to do a GCF with this one. So there's no GCF. We're going to go ahead and do the A, B, and C. We get 1, -1, and -12. We get -12 up in the top, -1 on the bottom. That means I need 2 numbers that are right next to each other to give us 12. That's going to give us 3 and 4. 3 minus 4 gives me a -1. 3 times -4 gives me -12, so we're good on that. And now when I go to write this out, remember, we still need that variable in the front. So we have a, and then our first variable, so a is 1, x, then plus 3. Then we're going to add that second variable on the back end for y. And then we've got x minus 4, and then add that y on the back end, and this is what we get. And then there's no GCF that goes into these, and so these are good to go. And so if you need to go back and do a little check just to make sure, we've got that x squared, yep. And then here we've got that 3 times that negative 4y, 3y times negative 4y, and that gives us that negative 12y squared. And so little tweaks for those, and they end up working out. Let's try a couple more. No GCF on this one. A, B, and C. These are now going a lot faster. These two numbers need to be 2 away from each other to get 35. If you need to write out your factors, then write out your factors. 3 doesn't go in, 4 doesn't go in, and then we've got 5 and 7. And then to get negative 2, 5 minus 7 gives me negative 2. And then I've got AX, then our plus 5. Add that second variable on the end. Then we've got x minus 7y, and there we have it. So now these become a lot easier. Okay, and let's do one more. Let's use some bigger numbers. So we've got A, B, and C. 1, negative 21, and 110. That means 110 is going to go on the top, and negative 21 on the bottom. We've got 1 and 110, 2 and 55. And then if we need to use our calculator, then use your calculator. Divisibility rules, if the digits add up to something that is divisible by 3, then it's divisible by 3. 1 plus 1 plus 0 doesn't work out. Let's try 4, and that doesn't work. Okay, and we get 5 and 22. Still not close enough to give us 21. And if you had to continue using your calculator, that's okay. You should end up with 10 and 11, and then of course there's no factors in between there. And so we've got 10 and 11. Negative 10 minus 11 gives us negative 21. So now I've got A, because that's my first variable here. So A, so A, which is 1 times A. Then we've got minus 10, and then don't forget to put that second variable on the back. And then we've got A minus 11B, and then that one's it. Okay, and so quite easy, not too bad when we have those two variable trinomials. Now let's go ahead and go into factoring 4 terms using grouping. So this isn't the same method that we did before, but once you know how to do it, this one is pretty easy, and I wanted a video where you could kind of do any type of factoring. So factoring with trinomials, and then that also worked with binomials, and then also doing 4 terms. So let's start with recognizing the GCF. So when we look at this first expression here, we notice that we have x minus 7 and x minus 7. And so these are really super duper easy. So we're going to think about that as the GCF. So instead of multiplying by the same monomial, it's multiplying by the same expression or binomial. So we have 2x being multiplied by x minus 7, and then we have negative 3 or minus 3 being multiplied by that x minus 7. So to write it in factored form, we're just going to do 2x minus 3 and then x minus 7. And that's it. And so now let's do it with the other one. So with the other one, we have this b squared minus 1 and b squared minus 1. So to write this out, we have negative 4b. And then don't forget that there's a 1 out here in front of this parentheses, set of parentheses. So this is going to be negative 4b plus 1, and then b squared minus 1. And that's it. And so this is step 1 to grouping with 4 terms. Let's see how that looks in action. So we have a 4-term polynomial here. The first thing you want to do is make sure that it's in standard form. For Algebra 1, they'll probably already have it in standard form for you. And then from here, what we're going to do is look for a GCF. So look for a number or a letter that shows up in all 4 terms. And in this case, we don't have a GCF. Now we're going to split this in half. And now from here, we're going to look for a GCF on both sides. So now, when I look at this one, I don't have a number that goes into each one, but I do have a letter that goes in each one. And if you need to put your ones and your exponents on these to kind of help you out, then do that. And so we've got G is going to come out to the side, and then we're going to divide just like we've been doing in our practice. And what we're only going to have here is F, and then the G's are going to cancel. Then we have minus 5, and then the G's are also going to cancel for this one as well. Then we're going to do the same thing on the other side. On the other side, I know that 4 goes into both of these, and then I don't have a letter that goes into both. My 4 is going to come down here, positive 4, and then divide. So 4 divided by 4 is 1, and then we've got F, and then negative 20 divided by 4 is negative 5. Now from here, this looks like what we just looked at, right? And so to write this in factored form, we're going to have G plus 4, and then F minus 5, and that's it. Okay, so now let's try another one. So with this one, I don't see a GCF showing up in all 4. I'm going to split it down the middle. I'm going to look for a GCF on the left side. I know 3 goes into both of these, and then they also have x's. And the lowest exponent that I see on the x is a 1. I'm going to write my 3x out to the side and divide. 9 divided by 3 is 3. 2 minus 1 is 1. And then negative 3 divided by 3 is negative 1. And then my x's cancel, and I'm left with a y here. Then I'm going to go on to the other side. I know 2 goes into both of these, and then I don't have a letter that shows up in both. So I have plus 2. And then 6 divided by 2 is 3. And then we're going to leave that x on there. Negative 2 divided by 2 is negative 1. And then we are left with that y. And now when I go to write it in factored form, I have 3x plus 2. And then I've got 3x minus y. And I don't need to put 1y because I don't need to have 1's as coefficients or exponents. And this would be my answer. All right, for this one, it looks a little bit more tricky because they're throwing in a decimal with this one. But we're not going to worry about it. We're going to keep doing the same thing that we've been doing. So I don't see a GCF that goes into all of these with that decimal there. I don't want to use 1.5 as my GCF yet. And so let's go ahead and do this left side first. So we've got 3 going into both sides, and then we've got x showing up in both. My lowest exponent on the x is a 1, so if you need to put those ones to help you, then do that. We've got 3x. 3 divided by 3 is 1. 2 minus 1 gives me 1. Positive 24 divided by 3 is positive 8. And then the x's are going to cancel. On this side, they threw in this decimal here, and so I'm just going to use that as my GCF, especially because I know 1.5 is going to go into 12. So I've got 1.5 on both sides. And remember what I said about the leading coefficient. If the leading coefficient is negative, whether it's on the left, on the right, or while you're doing regular factoring, if your leading coefficient is negative, your GCF needs to be negative. So this is going to be a negative 1.5. We're going to bring it down. And negative 1.5 divided by negative 1.5 is just going to give me 1 and then x. And then get out your calculator. If you need it, we've got 12, make that negative, divided by 1.5, make that negative, equals, and that gives us a positive 8. And then I'm going to go ahead and write this in factored form, 3x minus 1.5, and then x plus 8. If you end up with different signs here, it might be because you didn't use a negative GCF, or it may be that it can't be factored using grouping. And so especially with problems on tests, they might say select one of the factors of this polynomial, 4-term polynomial, where you would have to choose either the first one or the second one out of a list. And then one of the multiple choice answers could be none of the above, or it doesn't factor, or something like that. And so if you end up with different signs here, just go back and check your work, and then if you have that option where it's not possible, then it could be that, so consider it. All right, now let's go ahead and go on to this one, and we're going to go through this one a little bit faster. I don't see a GCF that goes into all of those. I'm going to go ahead and do my GCF of the left side. My 3s squared is going to come out to the side. 3 divided by 3 is 1. 3 minus 2 gives me 1s plus 2, and then my s's cancel on that side. On this side, I know 5 goes into both, but don't forget that leading coefficient is negative, so our GCF is also negative. Bring it down, and then we end up with s plus 2. So we've got 3s squared minus 5, and then s plus 2. And that is our answer. And now let's go ahead and do one more. So this is our last one. And notice that I have a GCF in the entire problem. So I can factor out a 2 out of all of these. So this is going to go out to the side, and then I'm going to go ahead and divide. So all of these are being divided by 2. Now from here, I'm going to split what I have in half. So I got rid of my GCF, and now I'm splitting out what I had. So now from here, I'm going to take my GCF of this side. I know 4 goes into both of these, and then both have m's. My smallest exponent is a 2. So my 4m squared is going to go out here. and then I'm going to divide. 12 divided by 4 gives me 3. 3 minus 2 is 1. And then negative 4 divided by 4 is negative 1. And then those m's are going to cancel. And then from here, notice that I don't have a GCF on the right side, but I can still factor out a 1. And I know normally we wouldn't use a 1, but we're going to see what happens here. So then now we get this plus 1 here, and then we didn't change what we had. Okay, and now I have those factors and I can write it in factored form. So I've got 4m squared plus 1, and then 3m minus 1. And then don't forget your GCF. The whole point of us taking it out is that it goes out in the front, just like we did with our previous problems when we were doing factoring. And our initial GCF goes out to the front. And then this would be our answer. And this concludes our video on factoring, so I hope you found this helpful.